Strava Belgradi. This is all I can say. I'm sorry. Can we have this? Excellent. Does this work? Excellent. Oh, the screen slightly. Okay, so we'll have to work with this. So it's a great pleasure to be here in Belgrade, and it's a great pleasure to be able to share with you some of the things in mathematics that I very, very much like. So to start with, let me tell you a little bit about some of the things that I do in the real world. So I use patterns and predictions to study where ships go. And so we use radar to monitor where ships go and to make sure that they move safely and securely through the area that we are responsible for. And you're thinking, what has this got to do with juggling? I'll come back to that. So we use patterns and predictions to see where the ships are going to go. And it's no surprise that we might be interested in protecting an object, and we have an exclusion zone. So the ship is not allowed in the circle. And when we see a ship, we think about which way the ship might be going. And in this case, the ship is going to go this way. And we can ask, is it going to get too close? Well, duh. Because it's already inside the circle. So actually, that's not the important question. The important question is, when will it get too close? And so by using simple mathematics, geometry, calculus, and algebra, we actually do calculate when these ships will be entering. And we use patterns to figure out the shapes of the ships, all to try to figure out where they are going to go. So here is a radar image. The ship is, if I can get the pointer to work, yeah, that one. Right, so here's the ship here, and here is the oil terminal that it's going to go to. And we can be analyzing the shape of the ship to try to work out where it is and who it is. And the idea is to try to prevent this from happening. There is a special term for this. It's called a bad thing. Okay? So we try to stop this from happening. And the mathematics that we use here is sometimes very simple and sometimes very, very complicated. Sometimes exactly what you expect and sometimes completely unexpected. This is what I do with my university that I'm associated with, which is the University of Kiel. This is Kiel in England, not Kiel in Germany. And believe me, people in England don't know where Kiel is either. So it's here. And so I'm associated with them, and to try to explain to them that the mathematics, the simple mathematics that they have learned, can be put together in complicated ways, and the complicated mathematics that they learn can be much more useful than they might expect. But my love, my genuine passion, is mathematics in unexpected places. So here we would expect this. What you don't expect is to find mathematics in juggling. Well, you might expect some mathematics in juggling. You might expect to think about how hard you have to throw, the angle you throw, the path that the ball takes through the air. You may have to think about the timing, tick, 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 whether it's slow, whether it's fast, whether it's irregular. Or you may have to think about also, yeah, yes. Fala. This will be, this will be a very long night if you clap everything very simple, all right? So, but the thing is that there is some mathematics that you do expect. But what we find is that there is mathematics that you don't expect. And about 30 years ago, some friends of mine and I discovered juggling tricks that had never been done. So after I've warmed you up, I'm going to get you to predict the existence of a juggling trick, which I will attempt. All right? That's where we're going. But I need to warm you up. I need to get you started. So first, I need to show you a little bit more juggling. So in addition to this, this is the first thing this is the first thing you learn. After a while, you do this. And then other things that you might learn are things like this, or like this, or like this, or like this. This is not normal, right? Okay, that's definitely not normal. Okay, so there are many things that you can do with juggling, but there are some things, as I say, which we did not know. So let me warm you up. Let me get you started. Let me get you thinking about patterns. So here we go. I'm going to start with a very simple pattern of numbers. Now, this is a game we have all played. I have in my mind a secret pattern, and it's your job to try to work out what that secret pattern is. And this one, I'll start with something simple. 2, 5, 8, 11. What do you think comes next? Everybody tell me. 14, that's the one that I heard the most of. Those of you who answered in Serbian, I have no idea. So if you said 14, yes, that's exactly what we would be expecting. Now, some people who have more mathematics might say, I don't know what the formula is, and I can make that last number be anything I want. And you're right, you can. But there is a very complicated area of mathematics which says that this is the best answer. Not just because I say so. It's associated with information theory, which is associated with data communication, which is critical in the world of the internet. I'm not going to talk about that. Let's do another example. So here we go. We get 1, 1, 2, 3, 5, 8. What do you think might come next? 13, 13. Do you know the name? Fibonacci, right. Now, Fibonacci's name was actually Leonardo. That surprised people. Fibonacci's name was actually Leonardo. But yes, those of you who haven't seen this before, if I take those two numbers, if I take these two numbers here and add them together, I get that. These two numbers and add them, I get that. These two numbers and add them, yes, I get 13. Now, the problem with this is that you have to read my mind. You have to get into my head, and that's not a nice place to be, okay? So let's actually do one where I don't have a secret. I will show you everything, and you can work this out for yourself. Here we have, it's nearly a circle. It's a circle if you look at it from down here. And I'm going to put 2 dots on the circle, and I'm going to join those 2 dots with a straight line. Here is your first difficult question. Into how many pieces have I cut the circle? It's not difficult. Go on then. 2, perfect. 2 pieces, because you can see I have the 2 pieces, one each side of the line. Okay, if I have 3 dots, how many pieces have I cut this into? 4. Okay, so we have 1, 2, 3, and 1 in there. There's an extra 1 in there. That's number 4. Okay, so with 2 dots, I get 2 pieces. With 3 dots, I get 4 pieces. With 4 dots, how many pieces do I get? Now, be careful. Be careful, because I'm going to have 4 dots and join every dot to every other dot. It's not 6. It's not... Oh. 8, 9, 10, no, 8. Well, let's have a look. Let's have a look. Let's put an extra dot and join it on to every other dot. How many areas do I have? I have 4 in the middle and another 4 on the outside. If you said 8, brilliant. Okay, now let me just go back. If I only have 1 dot, how many regions do I have? 1, yes, perfect, 1 region. So with one dot, I have one region. So if we have a look at this pattern here, 1, 2, 4, 8. If I have 5 dots, how many regions? Oh, look, let's have a look at it and see if we can work it out. Put an extra one here. I have 5 on the outside, 5 fat triangles, 16, 5 slim triangles, and 1 in the middle. 5 and 5 and 5 and 1. So that gives me 16. So here we go. We look down here and we have 1, 2, 4, 8, 16. So the question, what comes next? It's not 32. I did a talk a little while ago, and the lesson that they learned was never trust Colin. Because I fool people. The answer here is not 32. This is not a doubling pattern. Yeah, no. But I will tell you a little bit about where the pattern comes from. And here I have a triangle of numbers. Hands up if you've seen this triangle before. Okay, everybody, put your hand up. Everybody, put your hand. Everybody, go on. Everybody, put your hand up. Everybody. Now, if you have never seen this, put your hand down. Okay, good. Everybody put your hand down. Each number here is the sum of the two numbers above it. So to get a number, I look at the two numbers and add them together. This is called Pascal's triangle. It's a really interesting thing. But I'm going to show you where those numbers, 1, 2, 4, 8, 16, come from. And on this row, I will pick only that number. And that's 1. On the next row, I will pick these two numbers. 1 and 1 is right, 2. Okay. 1 and 3 is 4. And now I pick these three numbers, and you go, why are you picking those numbers? Let me show you the hidden pattern. Here are the invisible circles. And I'm taking 3 stripes through my pattern. So I now have 1, 6, and 1 is 8. And if I follow that, down here I have 1, 10, 5 is 16. And now I have 1, 15, 15 is 31. And that's the right answer. Why should you trust me? You shouldn't. In mathematics, we do not trust things that look like they work. We have to prove them. Now, I'm going to give you a hint of where the proof is here, but I'm not going to do it in detail. So don't panic. There's a thing called Euler's polyhedron formula, which says that if you have a shape like a cube, and you add up the number of pointy bits, which we call vertices in English. I don't know what you call vertices in Serbian. And then the faces, that is always equal to the number of lines, number of edges, plus 2. So let's try that with a cube. How many pointy bits are there on a cube? How many corners are there on a cube? 8. Right, so we have 4 on the top and 4 on the bottom. So 4 on the top and 4 on the bottom gives us 8, exactly. How many faces on a cube? 6, perfect. And how many edges? 4 around the top, 4 around the bottom, and 4 standing upright, and that gives us a total of 12. And 8 plus 6 equals 12 plus 2. In this case, it works. And if you go and study this, you will find that this always works for every polyhedron. And you may think, why are you doing this? Well, when we cut up the circle, we have regions, which are like faces. We have intersections, which are like corners. And we have lines, which are lines. So that means that the formula might be able to be useful, and it is. And we can use the formula, and we find that the number of regions that we get is this. This is horrible. This is absolutely horrible. There is an easier way of writing it, which looks like this, which is actually related to what Ben was talking about with possible hands in poker and similar. The mathematics is related. All mathematics is related. It's amazing. And so we can find that there is a formula. So the question now is, what happens if we don't just talk about one pattern, but we talk about a pattern of patterns? And now I'm going to take us back to juggling. So first of all, I need to tell you that when I juggle 3 balls, the balls take it in turns. If you watch the green ball, you will see that it goes green 2, 3, 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 green 2, 3. If I juggle 4 balls, I want them to take it in turns. I'll throw the yellow. I'll throw the orange. I'll throw the pink. I'll throw the green. And now it's the yellow's turn again, and it's still in this hand. So to juggle 4, you do this. And if you watch any ball, it stays in the same hand. But it's being thrown every 4th time. Look at the yellow ball, and we get yellow 2, 3, 4, yellow 2, 3, 4, yellow 2, 3, 4, yellow 2, 3. Look at the green ball, and we get green 2, 3, 4, green 2, 3, 4, green 2, 3, 4. They take it in turns, and they have to stay in the same hand. You have no choice if all the throws are the same. And if I juggle 5 balls, if you like this, you have to clap quickly because it doesn't last very long. But you'll notice that when I juggle 3, it's down here. Tick, 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 tick. When I juggle 4, it's tick, 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 tick. I need more time. I need more space. So when I juggle 5, tick, 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 tick. No, 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 no. Right. And go! I like to get a round of applause there because that is 1 year of my life. Seriously. And so now, let's follow this pattern. Obviously, if I do 6, I have to throw very high, and I do 3 in each hand. If I do 7, they cross over again, and they go very high. 7, cross. 6, don't. 5, cross. 4, don't. 3, cross. 2, don't. And when you juggle 2 with every throw the same, it looks like this. Because I throw the green, I throw the yellow, and then it's the green turn again. They have to stay in the same hand. When I juggle, okay, 5, 4, 3, 2, 1. By the way, this one I can do okay, so now that is very silly. But I just had all of you watching me stand here like this. Okay, no, 1. And of course, 0 is empty hands. So what I do is I describe this throw as a 5, this throw as a 4, this throw as a 3, this throw as a 2, 1, and 0. So now, if I juggle 4, it looks like this. Good. But I can do this. While juggling 4, I pretend to do a 5, then I pretend to do a 3, and then I go back to 4. The white is the 5, the green is the 3, and they must cross. 5, 3. Counting so you know when it will happen. 3, 2, 1, 5, 3. Did you see that change hands? I'll do it again, this time green high and white low. 3, 2, 1, 5, 3. Ooh, so close. Let me do it once more. White high and green low. 3, 2, 1, 5, 3. So I can throw to different heights. So while I juggle 4 balls, I do a 5, I do a 5, I do a 2. Actually, I should go, but I won't do this. I'll just hold this up. And then I go back to juggling 4. Yellow high, green high, and the pink being shown to you. Here we go. And 3, 2, 1, 5, 5, and there's the 2. I'll do it again. Green and white going high. 3, 2, 1, 5, 5, and there's the 2. I'll do it again. White and yellow going high. 3, 2, 1, 5, 5, and there's the 2. Okay, if you want me to do the pink ball, I can do the pink ball and hold up something else. So in the middle of juggling 4, I can do a 5, 5, 2, but now it's your turn. What comes next? Talk to each other. I'm going to give you 20 seconds to think what comes next. 20, 19, 18. Neon, fluorine, oxygen, nitrogen, carbon, boron, beryllium, lithium, helium, hydrogen. Go. What comes next? 5, 5, 5, 1. You have predicted the existence of a juggling trick. You have said that while I juggle 4 balls, suddenly and without any provocation, should be able to go 5, and then I should be able to go 5. I should be able to go 5, and then do a 1, and then go back to juggling 4 as if nothing had happened. And the amazing thing, this will mean nothing to you, but the amazing thing for me is in 1985, when I went to the British Juggling Convention, I showed people this juggling trick. 4 months later, when I went to the European Juggling Convention, people from America were trying to show me this trick because it was previously unknown. And we found it by following the mathematics of the pattern. So in the middle of juggling 4, I should be able to go 5, 5, 5, 1. Now, this is tricky to see. Starting with the yellow. Yellow, white, green. Counting down. 3. No, wrong color. Try again. And 3, 2. Well, my friends who perform tell me that if I do this, I should pause to build the tension, to make you wonder if this will in fact work. I wouldn't do that. Okay, starting with the yellow. 3, 2. Well, the other interesting thing about this trick is that in fact it's over very, very quickly. You have to know when it's going to come. So you have to watch the right thing at the right time. So here we go. Yellow, white, and green. So yellow, white, and green. Counting down, we get 3, 2. Well, the other thing that I wanted to... Sorry, let me do this again. Okay, so yellow, white, and green. This time for real. Okay, and 3, 2, 1, 5, 5, 5, 1. Now, that is over very quickly. Let me try to do this for you constantly. with no break. I have no idea what ball I'll start with. Probably the white. And 5 5 5 1 5 5 5 1 5 5 5 1 5 5 5 1 5 5 5 1 5 5 5 1 5 5 5 1 and drop back to doing 4. It looks like 5. It feels like 5. It sounds like 5, but it's only 4. And I've got you in my world because I said it's only 4 and some of you nodded. Okay? It's only 4. It's much, much easier than 5. And this is a way that you can use now to learn and to practice juggling 5 balls. It used to take 1 year to learn how to do 5. With practice and dedication, you can learn to juggle 5 in about 3 months. 3 months, right? An hour and a half every day. Don't do this, right? Just don't do this. Okay, so the question then, of course, is what if we keep going? What if we go beyond 5 5 5 1? What comes next? 5 5 5 5 0. You have predicted another juggling trick. Well, this juggling trick has a 0. It has an empty hand. So in the middle of juggling 4 balls, I throw high, 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 and then have an empty hand for 1 beat, and then go back to juggling 4. So here we go, starting with the white ball, counting down so we know when it will happen. 3, 2, 1, 5, 5, 5, 5, 0. And I'm going to do it again, starting with the green ball. And this time I'm going to help you see the 0. Starting with the green. 3, 2. And at that moment, yes. So it's one thing to see a pattern and to use the pattern to predict what might happen next and to be right, which is good. The question then is, what other patterns are there? And if we start to look at this, I can ask you to add up the numbers in each row. I'll give you the first one for free. 4. What's the second row add up to? 8. What does the next row add up to? 12. The next one. 16. The next one. 20. And they are always multiples of 4. And in fact, you can see which multiple of 4. Look at the middle row. How many numbers are there? 3 numbers. 3 times 4 is 12, and that is the number. That is the total. In fact, the average on each row is 4. Because on average, I'm juggling 4. I throw some high, I throw some low, but on average, I'm juggling 4. Does this always work? If I write down a string of numbers whose average is 3, will that be a 3-ball juggling trick? Well, here are some numbers that I've got. Let's have a look at some of these. Have a look at the top one here. The average of 4 and 4 and 1 is 3. Maybe that's a 3-ball juggling trick. Have a look at, well, this one won't work. The average of 4 and 1 is 2.5. That won't work. But above it, the average of 4, 3, 2, the average is 3. Maybe that will work. No. Never trust Colin. It turns out that these ones work and these ones don't. So what is the pattern? It is necessary that the average is the number of balls, but that's not enough. Necessary, but not sufficient. Well, I will show you the pattern, and together we will invent a juggling trick, which I will attempt. And if you like it, we'll do another one. Okay? So let me show you the rule. Let me show you the pattern. When I show some people this, they run away screaming, right, with their brains dribbling out of their ears. Don't panic. It's not as bad as it looks. All right, let me take it away. All right, so you've seen it now. Brace yourself. Are you ready? Here we go again. Here is the pattern. How do we use this? Well, we start here. And I know that looks like a strange place to start, but we think of the red blob as a place to stand. And we think of the arrow as a corridor that we can go through. And the number tells us the kind of throw to do. So if we start here, and we follow this arrow here, and we write down the number 3, and we do that again and again and again and again and again and again and again, then we get 3, 3, 3, 3, 3, 3, 3, and that gives us this juggling trick. But now we want more. So we go somewhere else, and now this is entirely your choice. Where else can you go from that location there? What other numbers come out from that? Tell me, 4 and 5? Any others? The 3 comes out and comes back to the same place. But that's all. So we can do a 3, 3, 3, 3, but we can do a 4 or a 5. This is your choice. See where it goes. Make up your mind. What do you want? So tell me, who wants the 4? And who wants the 5? Okay, everybody put your hands down. Who did not vote? Yeah, exactly. Okay, let's try this again. Who wants the 4? Who wants the 5? Okay, the 5s win. Why am I not surprised? Okay, so 5. We are down here. What can you do from there? 2, which takes us back. 3, which takes us across. Or 5, which takes us the other way. This is your choice. Make a decision. See where it goes. Are you ready? Who wants the 2? Who wants the 3? Who wants the 5? Oh, that's really close. Who wants the 2? Who wants the 3? And who wants the 5? Oof, okay, the 5 wins, I think. Careful not to box. Well, you can choose to box yourself in if you want to, but we've got 5, 5. Now it's your choice. We can do a 1, a 2, or a 5. It's your choice. See where they go. Make up your mind. Who wants the 1? Who wants the 2? Who wants the 5? Okay, the 1 overwhelmingly wins. We're back. I love you guys. I'm going to do a 1 on the end of that because I'm going to do 5, 5, 1, 1. Think, what will this look like? 5, 5, 1, 1. 5, 5, 1, 1. This was your pattern. If I can't do it, it's your fault. All right? Here we go. Starting with the yellow ball over here. Next time, 5, 5, 1, 1. Let's do it constantly. And we get 5, 5, 1, 1, 5, 5, 1, 1, 5, 5, 1, 1, 5, 5, 1, 1, 5, 5, 1, 1, 5, 5, 1, 1, 5, 5, 1, 1, and go back to doing 3. It works. Do you want another one? Yeah, you want another one. All right, so let's start again from the 3. Have a look where it goes. What can you do? You can do a 4 or you can do a 5. 4 goes across, 5 goes down. Make up your mind. See where it goes. Who wants the 4? Who wants the 5? 4's in. Okay, we are over. Oh, no, I mean, you picked 5 last time. Of course you're going to pick 4 this time. All right, you're over here. What can we do now? We can do 2, 4, or 5. See where they go. Make up your mind. Who wants the 2? Who wants the 4? Who wants the 5? Ooh, it's between the 4 and 5. Who wants the 4? Who wants the 5? I'm not really counting, don't care. All right, so we're down here. So we get 4, 4. Now, I really like 4, 4, 1, but this is your choice. You're not going to pick one now. You're not going to pick. Okay, so we can do 4, 4. Now, what else can we do from here? We can do a 1 this way, a 5 this way, or a 4 going all the way around there. So we've got 4, 4, and then either 1, 4, or 5. See where they go. Make up your mind, 1, 4, or 5. Are you ready? Who wants the 1? Who wants the 4? Who wants the 5? Why didn't you pick the 1? Okay, here we go. 1, 4. This is really close. 5. 5. Okay, 5. We're up here. Oh, what have you got to do now? You must do a 0. You have no choice. And now we can go back to the start. So we can get 4, 4, 5, 0, 2. So what does this look like? Okay, so 4, 4, 5, 0, 2. So I've got to do a 4, and a 4, and a 5. And while those are in the air, I will have a 0, and then I will have a 2, which is one of the balls. It will be that one, all right? So here we go. I've got to do 4, 4, 5, 0, 2. I'll start with the orange ball here, and I've got to do, with the orange ball, 4, 4, 5, 0, 2. All right, so it'll be the orange ball, I think. So here we go. It's from this hand over here. And we get 4, 4, 5, 0, 2. Let's do it again. And 4, 4, 5, 0, 2. And 4, 4, 5, 0, 2, 4, 4, 5, 0, 2. Oh, it's twice in a row. And it actually works. Why? Why does it work? Well, I'll show you the secret. You must promise never to tell anyone. This is being streamed live on the internet. You know that, don't you? You must promise never to tell anyone. There is a secret going on here. And what happens is this. The numbers in the circles are the forbidden numbers. And so what happens is when I say that I have 0, 1, 4, those are forbidden. So I can't have 0 or 1. I can have a 2. I can have a 3. I can't have a 4. I can have a 5. 2, 3, and 5. Are they forbidden? They are forbidden because there is already a ball scheduled to be there. And I must not put another one on top. Now, there is a way that you can juggle where you throw and catch more than one ball at once. I'm really not very good at this. But the second easy... Okay, this is the third easiest way of juggling 5. The second easiest way of juggling 5 is like this. And you can see there I'm throwing and catching more than one at once. The easiest way of juggling 5 is to put them in a bag and throw it up and down, right? So, no. But we have what we call landing schedules. And if we add 1 to every number, we get 4-ball patterns. And if we add 2 to every number, we get 5-ball patterns. So you'd hope that if we subtract 1 from every number, we would get 2-ball patterns. But what happens if you subtract 1 from 0? You get -1. And that corresponds to throwing an anti-ball. Because there isn't a ball there, and we want to throw one, so we end up creating ball-anti-ball pairs. And we end up making a connection with quantum physics. Can anyone speak Norwegian here? Nobody? Akkurat sånt det finnes en skapetsrelasjon mellom position og impulsor, finnes det en skapetsrelasjon mellom energi og tid. Well, it turns out we can actually create ball. I just gave the translator a heart attack, right? It turns out that we can actually almost do quantum physics in juggling. All of mathematics is related. And it turns up when you least expect it. It's things like this that really do make me do a little happy dance. Because they are fun. They are amazing. They make connections you never expected. And sometimes they turn out to be useful. Not always. Sometimes math is simply the chase, to understand why something is true. Just because it turns out to be useful, that's not the reason to do it. The reason to do it is because it's fun. Some people do it because it's useful. That's like playing scales on a piano because they make your fingers flexible. You play scales to learn to play pieces of music, the art. And that's why I study mathematics. That's why I love to find the patterns, the unexpected connections, and mathematics in unexpected places. And I hope you've seen how this can be a huge amount of fun, as well as occasionally being entertaining and exciting. Thank you for having me. Thank you. Thank you.